For today's webinar, I'm excited to say that we had a fan submission for this one. So today's is going to be a consumer product, actually in the same genre as last week's. So let's go ahead and jump over to the next slide here. As you can see here, we have a sink moving on from last week's handle from a commode or a toilet. And this week we're going to move on over to the sink in our bathroom series. So today, while this looks like a very simple model, there's lots of interesting things to show on this. There's lots of interesting techniques. So this one was a fan submission that someone sent in for me a scan, and I went ahead and reverse engineered this product. And I did it in certain ways that highlight some tools that are inside of Design X. So as usual, when I reverse engineer something, I have a disclaimer that you could give this model to 10 different designers and they would do it 10 different ways. So with that being said, I have an approach that I took, and I'm not saying it's the one right path, but it is a method that worked pretty well. And this model actually has a lot of interesting features and a lot of interesting things that it shows you when you're dealing with porcelain products like this. The accuracy of the manufacturing is low and things move around quite a bit. So this creates a lot of unique challenges to reverse engineering, which we'll get into when we actually do the Design X portion of the presentation. But before I jump into that, as usual, we talk about the scanner. So this one, I believe, was scanned with a handheld device. So this type right here, this one right here, that right there, maybe something like this. I don't have the bead on exactly which one was used for this one, but it was definitely a handheld scanner. And for these types of products, these porcelain products, scanning with a handheld is kind of the perfect scenario. It's very easy and flexible to walk up to this design here and scan around it, and you see that it doesn't have lots of fine details. It's nice, smooth flowing shapes, and again, that always works really well with handheld scanners. So that is what we used for this one. So let's go ahead and jump over to my comments about Design X themselves before we jump into the presentation. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you, but I just wanted to make sure that anybody that's watching this for the first time understands what Design X is really quick before we dive into the application. But Design X is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices. We're creating this type of data, and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter Design X. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right-hand side, whether these are the high-level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this Design X product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the Design X portion. So here is the model in all of its glory. That's the final model. And we'll do this combination setup this week where here's the final model. I'll roll back. And as I roll back, I'm going to stop at a couple key points and demonstrate some of the things that I did during the modeling process on this one. So we'll go ahead and roll back here. Turn on the mesh. So here is the mesh. And we will roll forward. So you can see the first groundbreaking technique that I used here is an extrusion. Now, one thing that I did do here is I overdrew it on purpose just to see that, or I drew it larger on purpose. And the reason why is I made the decision that because of the sides being swoopy and warped, I decided to keep that. With these porcelain molds, look at down the side there here. I decided to work with that and keep it that way, but obviously that's a design decision for whoever is reverse engineering this. So what I did there is I went ahead and just roll forward and turn on the surfaces. There we go. It's just did mesh fits on each side, which those were really quick to do. Turn on the regions here. So just doing this, we'll create a region, come over to Loft Wizard, expand it larger like this, like so. We've talked about the Loft Wizard many times, but I can't mention it too many times because so many instances I will bring it up and people haven't heard of it. So I want to make sure that everybody understands it because it saves a lot of time being able to just select that, have it create a loft, and even the ability to do this where I can do an accuracy analyzer and say, oh, man, I really want more detail in that area, and I really want more detail in that area, and I'm just holding the control key to drag that. And then if I want to relocate these without duplicating them, I can do that as well, where we just kind of move them around and maybe do it that way without adding more sections. And then when I'm ready, I just hit the checkbox and boom. I just created a duplicate there. And then we rolled forward here. I'll just go forward through all of those. There. So turn the solid on. And that last one, it wasn't showing. So there we are. And the other loft. And we'll do our trim extend cuts. Like I had to extend one because I didn't make it big enough. So we do that. So now you see here we have that nice organic aspect to it if you're trying to maintain that on the sides. I want that handcrafted aspect to it. So that is the phase one of what I did. So now let's jump forward to like another stage of this workflow here. So we'll just jump forward a couple steps. All right. So what I did here on this section, and we'll see here in a second, is I went ahead and pulled out this portion of the mesh, which if I turn this on, turn on the main part right here. There we go. All right. So now for this section here, there's a whole bunch of different ways you can go about this. Sometimes, I went ahead and went above and beyond with this approach, this technique here. And let's just roll forward and take a gander here. So we'll go ahead and cover this now, where we separate the mesh out into separate pieces. So this is a technique that I use on some projects where I don't just leave everything as one mesh. I separate and cut and paste the mesh out and do some editing to it. So you see here, we went ahead and removed all this stuff. So I will go ahead and show how that process works here, because I used a couple different techniques that aren't necessarily what you would think here. So to do that, I switched over to my other screen and use this same mesh, and we will break it apart. So one thing you can do is you can just do a Control C, Control A, Control C, Control V, and you see that I just created and pasted another mesh here, and then I can come over here and change the color back to blue. So that's one way. Another way I tend to do it as well is if I wanted to select a whole section this way, and once I have a selection that I want to use, and it just depends on what the geometry is, whether I do it this way, then do a Control C, Control V, and hide the other. So I just separated that mesh out. And then a lot of times I'll run the Polygons Healing Wizard on it here and let it run and repair stuff on the mesh. And then depending on what you can do hole filling and stuff, which we'll do here in a second on the other mesh. So let's go ahead and leave that. For this one, you could come in and look at it from the side, grab the rectangle tool, hit select through, do something like this, and disconnect the areas from each other. So if I do this too, so I just went and I disconnected the inside from the outside, and then if I use the paint bucket on this piece and then inverse and get rid of all of those pieces. So that's one way. And then you can use your regular tools. If I wanted to create this piece that I have showing over here, this right there, there's a whole host of ways, and most people are going to do they're going to use just the regular selection tools, maybe just come around, and you'll even see people come around with the paintbrush and just like go around and delete the pieces. So that's a completely acceptable way to do it. Using the selection tools up here, awesome way to do it, not a problem. But what I wanted to do is just show like another couple ways that I have also done it as well, especially if I just am in that mood where I want to be real particular and do things a certain way. So if I come over here to 3D Mesh Sketch, this is one way that I've often done it as well. So I come in here, go into 3D Mesh Sketch, grab the spline, And you see where I'm going with this. I can, if I wanted to cut this with a spline, I can do that like so. And you see, I mean, it depends. This might be faster. It might be a little bit slower. It just depends on which way you feel like doing it. And then I just disconnected that, and then I'm purposely staying away from the curvature of the fillet there, because later on when I go to like do a hole fill and stuff, it will that portion of it will cause the fitting of the surface to turn up on the end. So if I go ahead and just accept that, and then you can use this to trim a mesh. So you can say, I want to trim by curve. Select these curves here, and then hit next. And then it's going to ask you what you want to keep. So I'm going to deselect that and then select this. So whatever is that turquoise color is what I'm going to keep. And then you see I can turn off my 3D sketch. And you just see it's just a really clean way of doing something like this. And then for stuff like this, again, I don't have to do this. I'm just going above and beyond here, showing tools, because there are times where you do need to do this. And it's very beneficial to be able to come in and understand how to do all this stuff. Now, I can remove a lot of this stuff on the top level just by coming over to Global Remesh is one way, where I can just say 0.5, I'll reduce it down, hit OK, and smooth this using Global Remesh. Just give it a second to run. If I want to get really aggressive with the smoothing, I can run, smooth maxed out on this. Hit that. You see it smooths it pretty well. Another one is using enhance shape and maxing out the smooth. So you can say sharpness low on this part, overall smoothness max, enhance level max, and just smooth the ever-loving daylights out of this. When you're fitting a surface, it is nice to be able to do that, like to smooth the mesh ahead of time. And this is separated from that. So if you ever needed to go back to that original mesh. Another thing is I could use defeature here. So if I just come in. Now, when I do a defeature, you see that part needs to be defeatured as well. But when I do a long section, it sometimes will feel weird. So a lot of times I try to do defeatures of areas that are very proportional, because there's something about the way the hole fill that it's doing right there that is, I don't know, it makes it streaky triangles sometimes. If I do a long skinny defeature, that's just with the tool just is weak in that area. And then so you see here, but it's really fast to do when it's like a proportionate. And all that is doing is allowing me to delete and hole fill, right? So if I just do that manually here, we'll just select an area. So this area, if that was a bad area, this is basically just saying, okay, delete, hole fill, curvature, select, fill. That's all defeature is really doing behind the scenes. Now if I come over to hole fill, we can do a big partial here on the side. Like that. And then you'll see that we might need to do a little bit more when we actually, after we hole fill it. So as far as the fill type, sometimes I will fill it one way, take a look at it and you see the way it filled it. It's just got like a little bit of a ridge, so curvature isn't my favorite for this time. So let's try a tangent and do a fill partial. So that's a little bit better this time. And we'll just go ahead and accept that. And you see, this is what I'm talking about, where we might have to come back. And so if I come in and swipe up and defeature, we'll just do a long skinny one just to show you. There are times where it does just fine. I just think that sometimes the way it fills there, see that? And then the other thing you can do is smart brush and smooth. And then I have had instances where I'm trying to polish and make this beautiful, make this beautiful mesh where I've come in and refilled on top of a fill, right? So if I didn't like that, I'll go ahead and take a little more of the boundary. I'm just showing again different things that I've run into throughout the time using this software, just to show underscore all the different methods that you can have for and all the things that you can run into. So we'll go ahead and fill that and then hit OK. And then now you see that's beautiful. And then if I just come back with a slight smart brush here for that little witness line around the edge. Now, again, this isn't actually necessary for this. I'm just taking the time to show techniques that I've used that are really good for elaborate workflows where there are times where I might want to do something like this. The other thing that sometimes when I might do an auto surface to this, and for auto surface, if the edge is ragged like this, sometimes that ragged edge is more intense for the auto surface to fit to. So I also wanted to show a little bit of that. Like you can come in and say edit boundaries. And it's telling me, let's go ahead before we do that and run Healing Wizard first and clean up some of that stuff. And we'll just run that one more time there. Good to go. And then you can go to edit boundaries. You can say smooth boundaries. Adjust how many rows in, and then hit the checkbox there, and then have it smooth the boundaries. That's one technique to do it. Another technique for smoothing boundaries that I've used is if you come in and you go to 3D Mesh Sketch, and you see 3D Mesh Sketch, we're going to do a little bit more of this later here. But if I come over and I go to boundary and I say, let's fit a curve to the boundary, and you can adjust how close it fits, how smooth it is. Inherently it's already smoothing just by fitting the curve. And then I have it set to offset too. Like you could say offset in a certain distance too. So this is cool. I'm saying offset in 5 millimeters or 0. And we're just going to fit a curve to that boundary and hit OK. So now we have a curve. And you can come over here and you can say, I want to fit a curve to the boundary there, and then hit OK. So I'm using the curve, we'll turn it off, to create a beautiful, nice, clean edge. Check that out. Now, I could have also fit the curve, inset it, and trimmed it again if I wanted to, right? There's a bunch of different methods there. So, and the reason why creating this is then you can come in here, create a region out of this. I just have a habit of creating regions, even if it's not always 100% necessary. But create a region, then come over, and if I create this nice, beautiful polygon, it makes the fitting of, let's say, a mesh fit surface fit just super clean. And I could also use that boundary that I extracted to trim that if I want to as well. So you see here, and also when you have nice clean boundaries, if I need to extend them later, it makes it very nice. So now it fit it. I'll turn on my deviation just to show that. I could crank it to 11, give it more density. I think this is good enough, especially because this geometry that we're dealing with here is very warped. So you see we created that. We just fit a beautiful surface. Now, again, I went way, way above and beyond what I actually needed to do for this. But I just wanted to show a technique that if you really wanted to like reverse engineer every micron here, you can cut the mesh, smooth it, prep the mesh, fit the surface, and then even get real controlled about the edges and boundaries. So that is the mesh editing section. Let's jump back over to my other model and we'll see what else we have. So now we'll go ahead and jump forward, and here we'll turn on that surface. So we'll go ahead and hide these other four. What we did is, you see how it has that chamfer in here, this chamfer all the way around the inside. So we went ahead and it wasn't equally spaced, and this one was at a different angle than these, so I modeled them separately. So we want to reverse normal, trim those together, fillet those, created this one separately from those. And then one thing that I've highlighted before, you see this surface offset? The surface offset, we went ahead and used surface offset 0 to steal that top face, right? And then we'll just jump forward here and trim them together. So we went ahead and trimmed. We trimmed all of these together, fillet the other side, did a fill face on the bottom, sew it all together. Do the mesh fit that I just did a second ago. You see here, we went ahead and trimmed that stolen offset 0 surface. We trimmed it with this, and then we trimmed it with that to create this. You see that? Now if I turn my solid on, you see my surfaces, solid. Notice my solid does not stick up past that. So what we did here is we used some direct modeling. We went ahead and just did a move face and move it past And then right before we cut it, we applied some fillets to the tool. Sometimes it's easier to apply the fillet to a tool and then cut it away. Sometimes it's easier to do it on the solid. It just depends. So you see now that's cut. And then we went ahead and just did your basic revolve, merge it in with that. Now, let's see what we did next here. Now, this thing, there's a whole bunch of ways you can go about doing this. But in this one, I went ahead and settled on doing a loft along a loft wizard along a curve. So let me show how I did that real quick on my other software, my other instance of the software. So I can come in and do a 3D mesh sketch, and we will just turn some stuff off here. And we will do it on the main. You can draw it by hand. Let's just do that one more time. Okay, 3D mesh sketch. And then I can come in and just draw it, a spine down the middle, like that. I can also use like create section and just draw from the top. Like it depends on how accurate you want to be. But the idea here is that I draw that, and then you can create a region. So I can just do it this way. Insert, create region here. Now, most people forget this or don't know this, but when I come into Loft Wizard, most of the time when you click on it, you're doing it based on a plane, but you can also say based on a curve. And I can click on this, and you see that it makes the profiles follow the curve. And I can extend that out like that, and then dictate how many sections I want, and then hit OK. And then turn my surfaces on. So we just fit that, and then the way you would account for those other things is you come over here and you say, I want to extend both directions here. Like that. And then the same thing goes for the side. Create a region, draw a curve on the side, and use the Loft Wizard. So that's one way that you can do it. So now back over to our regular model. We'll just jump forward, like we said, to fitting that side surface the same way we just talked about. Extend, mirror to the other side. Fillet. And we'll just turn off the mesh there. Now, here's an interesting thing. I want to take a second. I showed the solid. When I modeled this, I want to make this a solid, right? See that? It bisects. This bisects the entire solid. I need to close this in as a solid. Now, in order to do that, what I went ahead and did is turn off the solids, turn on the surfaces. Just did a surface offset 0 and copied all those surfaces, and then did what we call a solidify. So a solidify is if the surfaces form a bounded shape. Those surfaces form a bounded shape. I can select them all and say solidify, and it'll create a solid. And then I can come over here and then just say Boolean merge them together. and merge that all together as one. Fillet that in, and we have a beautiful fillet there. At least I think so. Now, jumping forward, my first guess of doing the inside was, hey, let's do a mesh fit here. So let's turn the mesh on, hide that, and create this. Now, what I discovered is there is a ton of error in this. I fit it and I looked at it, and this thing is wobbly and warped and all kinds of stuff. So I wanted mine to be flat, even though I kept some of the warpage and stuff, right? So instead of using that, what I went ahead and did is jump forward here, turn on all of these guys. So I went ahead, turn on the solid, turn off the mesh. I went ahead and created a plane and converted these edges here. I converted all those edges to a plane, and I used those edges and I drew manually profiles. And then I extruded the center one sideways, and I created a loft between the edge of that surface that is here this surface, and I lofted from there, section, all the way up to the flat line. See that? That way, this surface ends up on its edges forming a square. I'm not even going to use this. I'm just using it as a tool to create tangency, right? And then mirror that across. We'll just do that. We'll mirror it across. Hide this guy. Sew it together. And we can get rid of our sketches. We don't need to see those anymore. Then I created a sketch from the edge of that and extruded it and trimmed it together to create this tool, right? And then I did a fill face on top and just made it and then sewed it together to make it a solid instead, because the Boolean worked better as a solid. So if I just say Boolean now, and then I turn on my solids and Boolean that shape away. Now, see, it matches up with the edges here. It comes right up to the edge. And then from there, come in and do a revolve cut for the drain. Apply your fillets to that. And then we added the drain here. And that is the workflow of how I went about creating this model from a fan submission. So somebody sent this in, and I went ahead and modeled it so we could talk about how we would approach modeling this sink. Again, I'm making design decisions. You may make different design decisions along the way, but this is just one approach of how you go about it. And I purposely took slightly off the beaten path methods sometimes, just so I could show methods and approaches that maybe I haven't shown yet in the webinar series.